Greetings everyone. Today we're going to be talking about properties of water. So water molecules have a polar covalent bond, and if you know anything about bonding, you know that there's several types of bonding. Um, Covalent bonds are between a metal and a nonmetal. In this case, they're polar. So we're going to talk about what polarity means and how it forms. Water molecules are formed between oxygen and hydrogen, and they form secondary hydrogen bonds, and we're going to talk about what that means in just a moment as well. All right, so polarity of water, this is incredibly important. This is the overall shape of a water molecule. It's formed with two hydrogen atoms and one oxygen atom. And as you can see, we have a giant oxygen atom kind of in the center right there with 8 protons in the center. Now, what's happening with this oxygen atom is it has a really strong electronegativity, and I know you're probably having a hard time grasping what electronegativity is because we talked about it such a long time ago. But electronegativity is the force at which an atom can pull on electrons. And it turns out that oxygen and hydrogen have wildly different electronegativities. So oxygen happens to win in the tug of war of electronegativity. It just happens to be able to pull all of the electrons towards itself. And so that's what those arrows are representing. So you see all of those electrons that are being shared inside of a covalent bond. Recall that a covalent bond is when electrons are shared, are all being pulled towards the oxygen atom. Now, when this happens, we get something that's quite strange, or something quite strange occurs. Now, um, look on if we kind of have to divide the molecule into kind of a top half into a bottom half, and look on the oxygen side and the hydrogen side. That's what we'll call the top half and the bottom half. But on the top half, the oxygen side, we happen to have 10 electrons. This is where all of those electrons have gone. They've been pulled up there by the oxygen, and we have 8 protons. Now, 8 and 10 electrons have a negative charge and protons have a positive charge. Now, this gives you a slight difference in charge. And so we end up getting a slight negative charge towards the end of this molecule. In a like manner, if you look towards the bottom side or the hydrogen side of things, well, the proton or the single proton that's on the hydrogen has lost an electron. The electrons have all been pulled away towards the oxygen side of the um, the atom. So what happens is, and so that here you can see the 0 and the 1. What happens is we get a slight positive charge, and so these two positive charges end up, or this molecule ends up getting negative and positive charges. That's what we mean by polarity. You basically get negative and positive charges. So when you get a polar covalent molecule, you mean you have a molecule that shares electrons, but it doesn't share them equally, and therefore you get charging on one end or the other of the molecule. So basically, our water molecule could be summed up something like this. You have a negative end and two positive ends. Now, this sets us up for another type of bonding that we learned about way back in a previous chapter called hydrogen bonds. Now, hydrogen bonds occur when the negative ends and the positive ends kind of attach to each other like magnets, and this is how ice forms, and this is how water droplets stay kind of sticky to each other. This is also why water has such a high boiling point. Now, water has a high boiling point relative to other liquids, and it's all due to hydrogen bonding. Hydrogen bonding is something that's really unique to water. It's also seen in other liquids, but it's very common in water. You see it. Water is probably the textbook substance for hydrogen bonding. And since everything is sticky, or since the each molecule kind of sticks to the other molecule, it doesn't like to let go of its partner per se, and so it takes a lot more energy to get those atoms to vaporize into a gas, and this is why it has such a high boiling point relative to other liquids. So, interesting fact about water, that's why water has such a high boiling point, is because of hydrogen bonding. One other fact about water, uh, remember we've been talking about solutes and solvents. And when you put something into water, we talked about something called disassociating. And this is how something will disassociate in water. This is a sample of salt, NaCl, and you can see that salt is bound together. But it turns out when you put it into water, it separates into some using something called solubility. So it turns out this is not soluble in water, and what happens is Na and Cl break up into Na and Cl ions. Now, notice that they have a charge on them, a plus and a minus charge on them. Well, water will segregate and associate with these ions in a very specific manner. Now, I told you water has a positive and a negative end. Well, it's going to also associate with the positive and negative ends of these molecules. So let's look at Cl first. Cl is negative, so the positive side of water is going to associate with the Cl. In a like manner, Na plus is positive, and so the negative side of water is going to associate with it. Just something you need to know about water. That's how things associate with it. Take care of yourself and please drink plenty of water. Thank you.